Welcome everyone to Cloud Computing and Big Data. Today we have our short lecture 14 about OpenStack. And the short lecture indicates that we basically reached the end of the course. We just give you a little bit of pointers really to much larger topics. And OpenStack is certainly an example that growth more and more. And basically we see more growth on a, let's say, yearly basis really of this technology, from 20 to 40 million, of course, that basically are served by OpenStack and basically this cloud operating system it provides. So it's a very interesting lecture. Unfortunately, a little bit short for those of you that are interested. In 2022, I had a longer lecture on this, and you can find that on YouTube. But today we will have just a short lecture because essentially this topic grows so much that we can have today full trainings of OpenStack and maybe a complete lecture series on all the details, how it is used, how it can be used, and so on. However, before we go, as usual, into the material of the OpenStack lecture, let us review what Marcel actually provided us the last time with our invited lecture 13. And this invited lecture 13 was, I think, quite important, firstly, because it's new. We didn't have that in the last couple of years, really. And one of the notions is really that hyperparameter optimization became more or less a standard now, right? So in previous times, people have done that manually. You see that a little bit also here, motivating a bit hyperparameters again. So you have different neural networks. You have a problem that you want to solve. Let's maybe have the CIFAR data set that also Marcel was alluding to in the last lecture with, very small pictures, really, 32 by 32 pictures of, let's say, 10 classes here. There's also CIFAR 100 data set for those that are interested. However, the key message to take away, we want to use a neural network, and the performance of this neural network, let it be ResNet 50 or let it be ResNet 18, whatever you have, it always relates to the hyperparameters, right? Or in, let's say, the majority of the cases. And you see a very good example in these three elements. So you have to pick yourself the number of layers, you have to pick yourself the number of neurons in all of these different layers, and a certain learning rate, right? So the learning rate was important for the optimizer, how quickly you go forward. And Marcel presented you last time a little bit an example how different it can be by switching to one hyperparameter configuration to another. So this was the example training then on the CIFAR 10 dataset with a ResNet 18. And you see the different performances here. So on the left-hand side, we have accuracy. Then we have the EPOS, where it is trained, this neural networks on datasets like the CIFAR 10 here. And you see different performances. And this is something which usually the user, you see here often humans, just pick wildly. So they sit in front of the computer. They think now it's time to learn something from the data we have in our company. And I think maybe the learning rate of 0.1 would be good. But maybe it's 0.01, but we can make another run. Now, if you have larger data, this becomes more expensive. So you want to think about it and think more clearly, isn't there a systematic approach to do this? And you see a little bit how interesting it can be. And Marcel was really talking about this much more in detail in lecture 13, where the small nuances here in the top, let's say those that really achieve the most accuracy, is not at all obvious, right? You see here 0.0029 achieved the best performance, and related almost at the, let's say, second place, if you want, is something called a learning rate like 0.16. So although you would say it's actually much more closer to 0.13, we see clearly the massive differences, right? So in this top league, if you want, and also the kind of third class league here. And this is something which is not obvious for us humans. So we choose this learning rate and basically train the models. We have to change then some other hyperparameters maybe. And that is now the more element in it, right? So when you think about that, we don't have one hyperparameter to choose from, right? Then maybe we could develop something like gut feelings and so on. And even that is a bigger stretch. But we have to choose from many different other hyperparameters at the same time. Hence, computing to the rescue. And this is something really which is important for you to take away from this course when you go to industry. Think about that high performance computing, cloud computing, they can do one thing very well, which is often commonly known. With more compute power, let it be in clouds, HPC, it doesn't matter so much. You can achieve a faster AI training, and many people will know that. So you throw more computing in it, and it will boil down the time to solution you see here basically on this graph. But what people usually don't know, and also in our industry projects, we see talking with SMEs, talking with industry about it, this HPO, hyperparameter optimization presented by Marcel, is not really known. That he used this computing power not only to achieve a faster AI training, which is sort of the first benefit you can tell if you want to convince your bosses to engage in these, let's say, clouds and HPC, you also can achieve better AI models. And we have that every single, basically, month with different SMEs, with different partners, where we can show this. And this is due to the systematic approach that we basically do in hyperparameter optimization. You see this a little bit alluding to what Marcel was basically presenting last time on RayTune. Ray is a bigger framework. He presented to you RayTune, which is really then the particular tool for hyperparameter tuning. Combining this with Horowat, doing then, of course, in a way, the more compute power combined with the systematic hyperparameter optimization that RayTune offers, gives you different trials that you see a little bit here in a way with different learning rates at the same time. And you can choose then on a validation set what might be the best model with the best configuration, and then train on the whole pot of data again. And chances are that this has much higher performance than, let's say, this little human picks some arbitrary values for the learning rate, or he sits quite long to do this over a year and finds it maybe by brute force over many, many, many runs. And this can have dramatic differences, as I was alluding to here. Then, also at the end of the lecture, I think Marcel did a very good job of saying this field is significantly growing. We today in research have something called neural architecture search, NAS, where we basically don't stick to the neural architectures or neural network architectures that are existing. So we want to have something new, basically, that's maybe also particularly tuned for the task at hand. So you cannot use always the same networks like ResNet 50 or ResNet 18. And then these AutoML techniques are a little bit derived from this, thinking that that what Marcel presenting you is AutoGluon was a good example of doing, let's say, ensemble learning. So it doesn't use just one model. The idea here is AutoML, make automatism realistic in terms of AI modeling. In other words, combining the power of neural networks, combining the power maybe even of old, more rather, let's say, regression techniques. And all of that is based on a so-called foundational model for time series, for instance, called Chronos that he also presented to you. So these foundational models would fill nowadays basically 3 to 4 lectures in a proper AI lecture. And we don't have that here. We have a cloud and big data lecture, but foundational models have been significantly now becoming important. They also save computational time because you can reuse a foundational model to tune to a certain problem at hand. And Chronos is a good example that he showed you of achieving also with our industry partners very good performance. But I also want to go, of course, into the material of this lecture today. It is a short lecture. OpenStack, however, could fill easily perhaps a whole curriculum in a whole university lecture. Hence, take away the message what I present here is really just a short lecture at the end of the course, giving you selected pointers to attractive topics that are really relevant. But today they are complete trainings on OpenStacks, where you basically can use many of these components that have been growing significantly in the last 5 years to create your own clouds, right? And some of that you have already used with the JSC cloud, and I will make a certain context to it later. But this is a good example that this is actually broadly used, and It's actually not used only in science and academia. We see also that many others like Walmart or basically Blizzard games that some of you know maybe from the gaming industry, they all use OpenStack heavily on a day basis. Hence, this is just a sort of short lecture to show you, what other topics might be very nice to study more in detail, especially if you go into industry and are confronted with the fact that your boss wants you to create your own, let's say in-house cloud, for instance. With this, we fulfill lots of promising starting from the beginning of the course. And we always said like, well, there's AWS, there's MS Azure, Google Cloud, the hyperscalers. Then we learned about Rescale, also some of you using that in the final project now. But, what about when you want to create your own, cloud at home, so to speak, at your organization level? And this is something where this has now different facets. So do you really want to program that from the beginning, right? So hence I bring you some basics today that will cover a little bit the scalability challenges really that you then have to implement, right? You have to remember even in data center design, lecture 4 that we have. So virtualization, scaling up horizontally, more users. You all have to program that if you want to do that in-house. Or, and that's the point now, you can reuse OpenStack like, again, a little bit like the Lego analogy, if you want. OpenStack has a big pile of Legos for you that you can stick together to create your own private cloud at home, still being interoperable with public clouds, like, interfaces we have seen already in the course, just making here some connection with the S3 interface, for instance, in storage, right? So in this sense, you can realize what we had at the beginning of the course is hybrid clouds, right? That we said there's some data, it's so sensitive, I don't really want to share. It has to remain in my organizational boundaries, closed garden, if you want. But then also there are some elements where I can use a public cloud, right? So maybe using standard interface, open the gate and compute some elements of it. And to realize it, to do this private cloud and then, bridging out to Amazon is basically possible with OpenStack. You can nicely port between different, cloud instances. You will also see the JC cloud enables to some extent also the migration from other OpenStack clouds, of course. And as this is a short lecture, I really cannot take the whole course of all these different components. I just make several connections because you have seen the containers already in this course. You have seen the relevance of computing, and then in context also storages, right? So the different storages we had in the lectures concerning a little bit the AWS services with object storage, block storage, file storage. Of course, then the idea is how you do it yourself when you do it in-house. You don't have the Amazon services, so you need some software stack that is ready to give you the same functionality or almost the same functionality, and that's where OpenStack begins. So let us review a little bit what OpenStack then is, where we have seen it already in previous lectures and how we can understand it now that it is open source and basically give everyone an opportunity to create a cloud in their own organizations if they want. So one of the, I think, important messages was here in this Kubernetes idea of containerized applications just recently in lecture 9, the platform as a service, if you remember, where we said, okay, we have some building blocks that gives us a Google Cloud. We had, the Google Kubernetes engine. We have these different containers that in turn are maybe based on Docker and so on. But here we had the choice of letting Kubernetes now, let's say, combine different clouds. And that is going now to the idea of creating this hybrid clouds, right? Of course, the GCP that we saw in this particular example is a Google Cloud is a hypervisor, a public cloud vendor, but you also see that Kubernetes can manage then your own data center. And, you can have also even other clouds like Amazon maybe. But here, the key message to take away is in order to do that, and today I would say before you start off or potter off and create your own software, please consider the OpenStack components, because it's really like a Lego big like pool of interesting building blocks to create your cloud. You will see that in a moment, that everything is already there. You need to just combine these different Lego blocks to create, let's say, a very nice, service. And that is what it is all about. Just to say that also OpenStack has become an enormous momentum and is also part of the Open Infrastructure Foundation. So it's really a top level project in this. So there is some certain, if you want, sustainability behind these software building blocks, that this will not disappear overnight, right? So hence, if your boss says you, well, please create my private cloud, and you go off and say, yes, I will do it. And then you provide it with OpenStack, and then the boss will say, well, that is an open source software probably dying in the next 3 months. Then you say, no, it seems to be quite sustainable. Many are using it. There's a foundation behind it. So this is here some reason to stay. And again, I'm not paid by OpenStack. It sounds sometimes like commercials, but I think it's a very strong technology that we have seen now in the next 10 years, probably more even advancing, while on the last 10 years, we have already seen it improving in terms of functionality, in terms of what building blocks, in terms of Lego maybe are already there. So think about now what cloud computing can do, data challenges that we had in terms of scalability, the data center itself, the horizontal scalability, that you see here. All of that you had to program if you want to realize this. Of course, even with OpenStack, there needs to be still the basis in physical components. So if you want to do a cloud in-house, you need physical hardware, right? So that's something what OpenStack cannot give you. But when you have physical hardware and your boss has decided, yes, please do it, or your CTO, then, the components of OpenStack on top of it enables you really to create, let's say, your own cloud software. Whatever it is you really want to do, it is, of course, highly dependent. Should it be a PAAS service, a SaaS service, maybe just a MapReduce for the company in-house, more on the platform as a service level? Should it be a SaaS solution for your clients in the company? That is not obvious. That will be, the material you have to discuss within the company. But chances are that you can actually realize this with OpenStack, and will be also this elastic notion with it, because the components of OpenStack are not just enabling new virtualization. They also really can be considered as what we would call something like a cloud operating system, right? So that really understands geographically distributed resources, that understands the cloud notion of scaling up, scaling down, and so on. So hence it has a couple of, let's say, core building blocks, right? So you can see again and reflect on what we had in the course. So we said a little bit of bare metal, so the infrastructure as a service model combined with virtualization. Then we had the containers, right? A little bit different from virtualization, still an important deployment topic that is then also based on the OpenStack idea of components. So if you dive deeper then, this cloud operating system gives you attractive dashboards. It gives you the opportunity to play with Kubernetes, kubelets, to really combine lots of those. And there's a nice, let's say, web GUI about, status, health status of all the different services. And you can go on and go on. Needless to say, there are APIs, software development kits today on OpenStack as well. So when you now think about the majority of topics we discussed in the course have been mostly about computing and storage solutions. Here we have, of course, also network components. As soon as you are in charge of creating your own cloud, you will see that the network plays a big role in it. Hence, there's also network components within the OpenStack infrastructure. And has also the flexibility to be, let's say, created for many different purposes. And I think this slide shows it quite nicely, that you have lots of impact in businesses. So Blizzard Entertainment should be something you would be quite interested in as students. Maybe it's a gaming industry. And in 2022, I gave more examples on this, because then it was a full lecture. Now we have basically introduced, other lecture parts as being a bit more prominent, but OpenStack is something which, you should look at. Hence, look at the 2022 lectures if you want to see more examples of Blizzard, or go to the OpenStack website to learn more. Similar impacts in Walmart, Open Metal, and many other industries. These are just 3 key examples. They have much more actually use cases on the side. Of course, for us, it's also interesting to see that all of these different use cases have a different way of combining really these services, right? And that's a key point. Also in JSC, you are using hopefully already with, your assignment right now. Maybe also even some of you have started with a final project to use it, to use basically the JSC cloud. And if you look more deeply, what's happening, JSC cloud is nothing else of using this Lego bricks and pieces of OpenStack in the terms of computing network and volume services, and then basically integrated in the HPC landscape of JSC. Hence, you can also combine it, of course, with more OpenStack services, but it also enables us to basically migrate or port your application from other OpenStack clouds easier, right? And this is a key idea now of having a sort of standardized OpenStack cloud operating system. So the porting migration is much more easier. If you remember what we said about being trapped in a vendor lock, maybe in public clouds, having a specific AWS services and so on, or MS Azure HD Insight, so how we can, migrate maybe to the Google Cloud Platform. That is not so easy if you don't use Jupyter Notebooks. If you just use SageMaker and other tools, it is increasingly difficult to migrate really from one cloud to another. And OpenStack has at least a sort of standard set, even if it's just standard services, right? Not at all directly, maybe like SageMaker, but still offers us the opportunity to really change clouds as needed. And another key message I wanted to leave you on the table is really the scalability concern. Think about that these cloud components we talk about, if you have to program it from scratch, you have to talk about many of these metrics we learned very early in the course, right? So size, scalability. The idea of the cloud is really removing, computational power, storage as needed. Hence a cloud paradigm, shrinking or provisioning new resources. Then the software itself needs to be ready for it, right? If you want to have, MATLAB and then put it on 10,000 GPUs or 1,000 GPUs, it will not make a difference because it has parallelism in it. And there's a parallel toolbox with it that can do some of these things. But this is a good example of saying that software needs to be scaling as well. So you come to more and more requirements, really, that when you want to do it and create essentially these services we have seen from scratch on your own, then you come to lots of different concerns. And you see here again, application scalability, technology scalability is all, let's say, orthogonal factors that we have to then also take in mind when we want to develop this, when we want to use the data center at scale. And basically that is, of course, what the cloud entails. Hence, OpenStack is there as a component set, really. And you see here how large that is. And that's why I say also today, in 2024, we should probably have rather, let's say, whole trainings on OpenStack, if you think about it. So that is not something what we can teach just in one university lecture. So you see there, OpenStack has actually services in computing and storage. That's what you already know, and that's what I will talk about. But it goes way beyond that in network, hardware lifecycle. It has shared services now, basically, that you can use with whole different lifecycle management services. It goes into the development area, even with much more SDKs. You see that a bit here, like command line interfaces. So all of these are interesting facets and need a lot of teaching to do that. And hence we cannot do this anymore in one basically university lecture. Hence this is more or less a point of view, just to say that before you, again, start from scratch implementing, really look at OpenStack. You don't have to have all of these components at once to create your cloud. And now that's the point when I come to the remaining part of this lecture. Let's pick a couple of pieces of this Lego bricks and see how we actually would realize this with OpenStack when we compare it a little bit to the hyperscalers, right? Like Amazon, for instance. So this is one of the services we also learned very early on and then manifested in the area of infrastructure as a service in lecture 8. So here we talked about EC2 services, also fueled a little bit by virtualization. And we want to see how that is realized when we now basically use these OpenStack services. Obviously, we have basically a combination of different of these Lego bricks and services in order to make that happen. And that is the beauty basically of this interesting cloud operating system. If you want, you can combine it in different ways in order to solve different problems. So in the heart of what we see here is the goal of essentially using VMs, virtualization, as you know from lecture 4. But we have also learned there are lots of services around it when we were using it with AMIs, for instance, right, in Amazon. The Amazon machine interfaces, images which are already, let's say, have installations of some deep learning packages, for instance. Hence, these volumes that we would have and then instantiate, right, and maybe putting then these images on a computing node needs to be stored somewhere. It's basically also where Cinder comes on. Then we also need some computing power where basically the provisioning of VMs can, start. The glances are the key images that we have in the, idea of saying what is it in terms of virtualization images that we can instantiate within the VM, plus the storage itself. All of that needs to be quite nicely connected. And of course, on the top, we have some authorization, some controlling with UIs, seeing the status, monitoring, and so on. So you see a very good example of how basically this VM provisioning would look like if you basically want to do it with OpenStack. You have to install, you have to use different services, but basically you will end up in something which is very similar actually to the Amazon idea or to the MS Azure idea, where we had similar things of also using virtualization technologies. A bit more on elements when we think about the idea of the building blocks that are now realizing that at scale there are different services involved. One key service is then really the Nova service. It stands essentially as a compute service in the context of virtualization. If you remember, the virtualization is a key paradigm in clouds. Hence, this is one of the key services using Nova, mostly in the OpenStack services, and different building blocks that you still gonna need, right? If you want to do this now at scale, if you want to schedule this really, on which really hardware you want to do things. Hence, the different roles that you see a little bit with the scheduler, the APIs, the databases, and also the keystone, again, authorization, neutron, in order to understand where we can basically schedule and where we find a placement then of the kind of instance of the virtual machine, right? Think about the cloud has many, many compute power available. Now you have to schedule all of this. And again, this is something you don't want to create from scratch. Hence, you can use the idea that you see here, a little bit of the Nova service, which inherently has an API, a conductor, a scheduler, and then, of course, using the computer with some certain hypervisor, already from the virtualization lecture, in order to really then get the VM on some computing node somewhere in your own cloud. Hence, this topic is not so simple. In one respect, it goes back now, if you want to have just a virtualization service within your company, to really understand all of the things that you see here on the slide. So, well, how basically you get access to these systems, Keystone, how you basically use Nova now, the compute service on very different, let's say, hardware that you have in the company, how you have the VM images basically provided to be instantiated and then run in the hypervisor that you see here in red. So this is another service. And you need to carefully control, configure all of them. Still, it's worth the effort, because if you want to implement it from scratch, you will spend probably years to make it really scalable. And you see here a very good example that this really works. By combining all of these different elements, you really can do this and have all the benefits then. That's a key aspect. So of course it will inherent support the scaling part, right? So if you want to scale up and down your services, that is where Nova can help you. You don't have to implement it yourself. And this is something where it enables you then what we know from the data center design, this horizontal scalability, right? So if you need also then more, and you see that a little bit here with the different elements behind, right? So if your users in the company get more and more and more, and your boss says, okay, that's instead of 50 support, let's say also our supply chain friends, so 500 people suddenly using this, you can actually extend this to the compute, given of course that the hardware follows a little bit through, but your cloud setup doesn't need to be changed, right? So basically you have already with OpenStack a service landscape that is able to scale in terms of workload, and this is where the benefits come from. Hence, it is used also in industry quite often. I was giving this example a couple of times, just coming back to it in lecture 8. And if you want to know more, there's also a nice, let's say, video around it. But it really shows what impact there is. Also having this different infrastructures, where you think about, Volkswagen creating the next generation of the Golf maybe is something what you don't really want to share with many others outside. So some of the simulations, some of the early design in terms of computer-aided engineering and so on of applications, you maybe want to keep in a private cloud before you go to the public cloud to compute some, let's say, maybe more costly fluid dynamics or something else. So this is just an example of saying that, of course, the car industry is interested and many other industries as well. And the idea is even that these big companies, of course, could afford to basically hire someone who is creating this all from scratch, but there's really no need to do so. Then going one step further, when we learned later in the course already that virtualization is a very cool technology. However, it carries around always the operating system. With this, have a very high, if you want to, gigabytes footprint or storage footprint. Hence, isn't there something better, which is a little bit more, let's say, vendor lock free, not a specific operating system, and so on. And we came quickly to the containers, and guess what? In terms of just using Nova maybe as a compute service that is optimized for virtualization, as we have just seen, also OpenStack provides you with the Sun services, which is then the containerized services that can digest Docker containers. And with this, you have all the benefits. Just remind you of what we had already in lecture 12. Think about that Docker is a bit more, let's say, slim in terms of storage needs, slim in terms of management. You don't have, this hypervisor / guest operating system activities anymore. Instead, you have the so-called Docker engine. And basically the idea of the container then is that you have all the dependencies, everything isolated within this container, almost this analogy that we have also in the large container ships here that you see in the port, even in Reykjavik, if you want to go there. Then basically you come to something we always call the vendor independence. And this is, of course, for you in the companies or basically even in academics, sometimes a really win. So you can shift around these containers in different clouds, depending on what pricing models you get. And with this have huge benefits. And of course, now think about this hybrid factor that we discussed as motivation. So you would say, well, I have a private cloud on containers, so with Sun services in the OpenStack world, but I want to, at some point in time, every now and then would reach out basically to the Google Cloud Platform. And then, of course, you can do this nicely because you have containerized your applications and can just shift the container if you want into the public cloud, compute several bits and pieces that you want on the public cloud, and then return home if you want to your own private cloud. So containers are really enabling technologies, hence it's nicely supported in the service landscape of OpenStack with the Sun service. You see a little bit how that works here with the Sun API and the Sun Compute. that in the end, of course, is relying also again on different services. And this falls back again to the idea that you have to combine them in order to create, let's say, a really complete service solution. Sun itself is just one small Lego brick, right? You cannot do much with it. But with having the glance that, for instance, then can store images, the keystone that we know already does some authentication, so the security parts of it. And then you need, of course, here some element of a container service where the courier comes in. So it's basically enabling us different elements. And the key message to take away is, of course, when you do that on your own, there will be a massive, let's say, impact also how you configure networks. Hence the neutron service that you see here magically behind the scene that we never really much discussed in the course, because if you use infrastructure as a service, PAAS, SaaS, whatever in the public clouds, that's not your concern so much. You can fine tune, there are some options, but still that's something you don't really need to work on a lot. But if you are in charge, you have to think about, how Neutron maybe can help you to set up the network in a company in the right way, also enabling us then to have complete control about the different OpenStack components and the network connectivities. Hence, let's come to a couple of examples. As I said, a short lecture, so we go a bit more quicker here, showing you some of the examples that you already know. The S3 interface we had here in the object storage quite some time ago already. So this is something where there are different storage solutions that we have seen the public cloud examples from Amazon. And I think that's something that you can also look at again. There was even a file system storage available. And all of these three that you saw a little bit, the hyperscalers, right, in different lectures beforehand, I just want to make the connection to this, lectures we learned. Similar services are actually provided by the Swift service with the object storage that then can scale up, can scale down. You have just objects putting it in, and can be different examples that you basically have, like storing photos and so on. But it has interesting management features like, again, the replication schemes, distribution, and so on. Then the Cinder service was more the block storage. As we said, also, some people may use it more for, this VM management, images, and so on, where basically it has a complete block where you store data. And, we don't really know necessarily where exactly that is. That's an important part of this block storage. And the files is now something we can relate to, like a file system. And this is something which is also then where the Manila service comes in. Hence, under the storage category, as we have seen with the compute category with Nova Sun, there are different exactly possibilities how to use, let's say, the hardware components of the cloud. And also for you in a company, you don't have to provide maybe all of these three storage solutions. Maybe the object storage is just enough by using just Swift. And then to connect just maybe finally a little bit to the lectures we had also in the beginning of the course when we talked about big data analytics. You remember HD Insight with Apache Spark. We talked at that time, using so-called a worker and, master paradigm. You see that a little bit here also, how nicely that can be supported. Apologies for the slave here, it's an older graphic perhaps, but the master worker paradigm is also quite nicely supported, enabling again horizontal scalability, meaning that we can do more and more of these nodes and data nodes and connecting this with the same name nodes, enabling us much more scalability in order maybe to scale with the data we need for shopping data analysis. You know that by now, we have seen that in lecture 11, that sometimes shopping data can be quite tough, can be quite a lot. And then you need, let's say, lots of these kind of different nodes to really do the frequent pattern mining, which is also implemented partly in Spark, like the FP growth, the tree-based algorithm that Shadi was presenting you, for instance, or that you also use in your practicals. So something we learned early on, but here we basically have it now as an option of saying, what can we do to do big data analytics at home, right? In my own organization. So, and this is where then OpenStack comes in. Exactly this model is supported. You can basically have different of these elements, of course, already pre-configured in the OpenStack marketplace. But you see that the kind of services that you need to realize this is coming back to this basic services, Nova for compute, right? Especially if you think about the yarn that was basically doing all the scheduling in the Hadoop and Spark world. So this is something where you can use a sort of resource manager to schedule your own cloud at home. Then the name node is again a computing combined perhaps with some Cinder storage, where you want to have some lookup functionality, where you have some metadata of all the different nodes that are available, the data that resides in the data nodes. And of course, come back to lecture 5 if you have a bit forgotten about how that master worker paradigm works. And then the node manager is then really doing the computing in itself, the tasks, if you want, coming down. And then also the data node is important, where again, Cinder plays a role to also give you then access to data. Hence, you can model this Hadoop, if you want, on your own by using OpenStack Lego bricks. And this is something where even others have thought about it. You can go to the marketplace and reuse components which are there. Now I could go on and go on. So even in previous lectures, I was showing you different blueprints. If you go to the OpenStack website, they will give you reference architectures of many different, let's say, problems where clouds can help also within an organization. So hence, I would encourage you also to look deeper on the OpenStack website. Hence, also the 2022 course that I had a course lecture on OpenStack. Maybe that's also something for you. And of course, for those of you who want to again understand why OpenStack, this YouTube video is also quite a nice resource. So we continue with short lecture 15, essentially after this one, after a short break. So see you then.